For this unit, we're going to be classifying different types of quadrilaterals. And your essential question is, what information can I use to classify quadrilaterals? So if you don't know what a quadrilateral is, quad means four, and lateral means side. So a quadrilateral is any figure that has four sides, exactly four sides. So we're going to look at some different types of quadrilaterals that are special, and we're going to talk about their definitions. So you'll need to be sure to write these down in your notes because you will want to use them later. Okay, so first is a parallelogram. A parallelogram is a quadrilateral, so it has four sides. It has two pairs of parallel sides. So we are going to mark those on the figure, and I want you guys to know what these markings mean because you'll need to know them when you see pictures in your book and on different types of problems. You'll need to know what these symbols mean. So to show that sides are parallel, you put little arrows on them like this, and so this shows that this side is parallel to this side, which means that they go the same direction and they never intersect. Okay, now this side on top is also parallel to this side on bottom, but they're not parallel to the sides that we just marked. So we're going to mark these with two arrows like this to show that this is one set of parallel sides and this is another set of parallel sides. Now there's different types of parallelograms. If you get more specific, a rhombus, most of you guys would probably call it a diamond, but we do not call it a diamond, we call it a rhombus. A rhombus is a type of parallelogram, and it has to have four congruent sides. So that's the part that's really important about a rhombus. A rhombus has to have four congruent sides. Now notice it also said that it was a parallelogram, so it's going to have two pairs of parallel sides, like the definition of a parallelogram, but it's also going to have four congruent sides. So we're going to mark all of those things. So it's a parallelogram. This side on top is parallel to this side on bottom, and this side over here is parallel to this side over here. So that shows our two pairs of parallel sides. And then we're going to show that it has four congruent sides. So to show that sides are congruent, you make a little tick mark in the middle of them or wherever on the side. And so all of these sides are congruent. They're all equal. So they all have one tick mark to show that each of those are congruent to one another. Okay, a rectangle is also a type of parallelogram because it has two pairs of parallel sides. But to be a rectangle, most specifically, it has to have four right angles. So we're going to mark that it is a parallelogram. We're going to show that this side is parallel to this side with the arrows, and the top is also parallel to the bottom. So we've got our two pairs of parallel sides, but it also has four right angles. So we're going to mark those. So to show that an angle is a right angle, that's noted by a little square inside the angle. So this shows that it has two parallel sides, two pairs of parallel sides, and four right angles. And there's one last type of parallelogram. This is a square. So a square is a parallelogram. It has two pairs of parallel sides, and it has four congruent sides, and it has four right angles. So what is something that has four right angles called? It is called a rectangle. So a square is a parallelogram because it has two pairs of parallel sides. A square has four right angles, so it is also a rectangle because that's the definition of rectangle. And a square has four congruent sides like a rhombus. So a square is a parallelogram, a square is a rhombus, and a square is a rectangle. So it's just a really specific type of each of those things. So we're going to mark all of these. So we're going to show that it has two pairs of parallel sides Hold on, I'm going to go back and erase those and make them the same color. So we're going to show that it has two pairs of parallel sides. Here's one pair, and then there's another pair. And we're going to show that it has four congruent sides. So each of our sides has a tick mark to show that it's congruent. And it has four right angles. So we're going to show the right angles with our squares inside. Alright, so that's all for types of parallelograms. The next kind of quadrilateral that we have is a kite. And a kite has two pairs of adjacent sides congruent, okay? So a kite is a quadrilateral that has two pairs of adjacent sides congruent. Adjacent means side by side, in case you didn't know that. You can add that to your notes, side by side. Okay, so that means that this side is congruent to this side. These are adjacent to one another. They're next to each other. And then we have this side that's congruent to this side. So the top two are congruent to one another and the bottom two are congruent to another. So notice I have one tick mark for these ones that are equal and two tick marks for these ones because these are different sizes than the ones up here. Okay, now technically a parallelogram, a rhombus, or a square could be considered a kite depending on how you drew it. So a rhombus, if I draw a rhombus like this, okay, this side is congruent to this side and this side is congruent to this side. They just all happen to be congruent. So technically a rhombus is also a kite. A square, if you draw a square, okay, this side is congruent to this side and this side is congruent to this side. They just all happen to be congruent to each other. So technically a rhombus and a square are also considered a kite. Now if I drew just a general parallelogram like this side is not congruent to this side, so that would not work. Okay, so only a rhombus and a square could also be considered a kite. All right, trapezoid. Trapezoid is a quadrilateral that has exactly one pair of parallel sides. So only one pair of the sides is parallel, not both. You can only have exactly one pair. So in this trapezoid, this top is congruent, or not congruent, but this top is parallel to the bottom side. So we're going to draw our arrows on there to show that those are parallel. Now this side over here is not parallel to this side, so it does only have exactly one pair of parallel sides. So that makes it a trapezoid. Now we have one last one, isosceles trapezoid, which is a type of trapezoid, which means that it has one pair of parallel sides. That's what that means. Notice I use the symbol for parallel. So this side is parallel to this side, okay, but the non-parallel opposite sides are congruent. So this non-parallel opposite sides are congruent. So that means that the sides that I had before that were not parallel to each other, so this side and this side, are congruent to each other. And that makes it isosceles trapezoid. Now, some people have trouble with the word isosceles. I think that that word looks like the word socks, and that means that you have one pair that are the same, right? So isosceles means it has one pair of sides that are the same. So isosceles looks like socks. That's how you can remember it. Okay, we're going to go through a few examples of how to use this information. All right, so it says determine the most precise name for quadrilateral LMNP. Okay, well, I can kind of determine what it looks like, and then I can see which one is the most precise name if I want to. So what I can do is I can find, if I want to determine like if these sides are parallel to one another, then what information do I need? How do I know that lines are parallel to each other? What do I have to compare? Well, you have to compare the slopes. So we can find the slopes of this side and this side and this side and this side and see if they are parallel. So I'm going to find the slope of side LP. So remember, I'm going to take y2 minus y1 over x2 minus x1. So I'll write that formula over here in case you forgot it. That's the rise over the run. So you can also just count since we have it on the graph if you'd want. So you would have, this is down 1 over 2. So I have negative 1 and 2. So my slope is negative 1/2. Okay, if I check line MN, then I go down 1 and over 2 again. So that also has a slope of negative 1/2. So I know that LP is parallel to MN. Okay, now I can check the other two sides also. If I check line LM, then I go up 1 over 2. So I have 1/2 as the slope. And over here, I go up 1 over 2. So from P to N is also 1/2. So LM is parallel to PN. And I almost forgot to put my bars on there to show that those are segments. So I'm going to go ahead and do that now. So these segments are parallel. So since it has two different pairs of parallel sides, let me erase this, I know that this side is parallel to this side, and I know that this side is parallel to this side. So it has two pairs of parallel sides, so it is a parallelogram, okay? But I want to see if it's even more specific than that. So I need to go back and look at my different types of parallelograms. I had a rhombus, a square, and a rectangle. Well, I know that it's not a rectangle because a rectangle has to have 4 right angles, and you can pretty much tell that these are not right angles in this shape, and so therefore it can't be a square either because a square also has to have 4 right angles. So now I just need to check to see if the sides are congruent, to see if they are congruent to be a rhombus. So now we're going to look at the distance between these different sides to see if they are congruent. So what I could do is I could find the distance between L and M. So remember, our distance formula is y2 minus y1 squared plus x2 minus x1 squared. And you can do the x's first or the y's, but we're going to end up adding them together anyway, so it's not going to really make a difference in our formula. You can also do, remember, this distance formula comes from the Pythagorean theorem, so you can also just check to see what the third side of your triangle would be. So if I'm doing from L to P, I'm finding the distance. This is my triangle right here. So this side is 1, this side is 2. And so I have 1 squared plus 2 squared equals c squared. So remember, I do 1 plus 4 would be 5 equals c squared. And so I take the square root. So the square root of 5 would be c. Okay, now if I want to check Pn, if I look at my triangle, this side is 1, this side is 2, so it's also going to have the same thing. And then if I look, so Pn is also going to be the square root of 5. If I check this one, this triangle would be up 1 and over 2, so it's going to have the same thing. So nm is also going to be the square root of 5. And then if I do this one, I have this side is 1, this side is 2. So it's also going to be the same as the others. So Lm is also going to be the square root of 5. So I now know that it has 4 pairs of congruent sides. So it's also a rhombus. Now, which is more specific? A parallelogram or a rhombus? Well, a rhombus is a type of parallelogram, but it has to have 4 congruent sides. So a rhombus is actually the most precise name for this quadrilateral. All right, one more thing that we can do with properties of quadrilaterals is find some missing variables. So it tells us that this shape is a kite. And so I need to go back and think about, what do I know about a kite in order to find the values of the variables? Well, I know that a kite has 2 pairs of adjacent congruent sides. So I know that this side is congruent to this side, and I know that this side is congruent to this side in order for it to be a kite. So let's think about how we could use that information to write an equation to solve for the variables x and y. So I know that 2y plus 5, that side is equal to x plus 6. And I know that 2x plus 4 is equal to 3x minus 5. Well, I can't really solve this one because this one has an x and a y, so I can't really do anything to solve that one. So I'm going to look at this one because this one has just x's in it. So remember, when you have variables on both sides of the equal sign, you can't just put them together because one's over here and one's over here. And to keep the equation balanced, I have to do the same thing to both sides. So you need to cancel out one of the x's. So I'm going to subtract 2x to cancel that one out. And then I have 4 equals x minus 5. So then I'm trying to get x by itself, so I would cancel out the 5 by adding to both sides. So I get that 9 equals x. So that's one answer. So now that I know that x equals 9, how can I use that in this equation over here to help me find the value of y? Well, if I put a 9 in for x up here, then I have 2y plus 5 equals 9 plus 6. And then I know that 9 plus 6 equals 15. So now I can solve this equation. So I'm trying to get y by itself, so I need to cancel out the 5 by subtracting. And then I have 2y equals 10. So I need to divide by 2 to cancel that out. And so then I get y equals 5. So those would be my answers. All right, so now you need to go back to your essential question and use that to help you write a summary and complete sentences. And then also be sure to write your 2 potential test questions in the left-hand side of your notes. Thank you.